We are going to talk about lesson 10.4 now. So in 10.4, we're going to talk about how do we decide which hypothesis test to perform. So we have this little flow chart here that tells us the first thing we need to ask ourselves is what is the parameter that is being addressed in the hypothesis. So what's our key word in there? And we're looking for proportions. Usually in a proportion problem, it won't actually say the word proportion, but it's going to say something like this many were in favor of, or something along those lines. And so in that case, we're going to do our proportion stats in StatCrunch that uses a Z statistic. And in that, we should make sure that we are checking the NP times 1 minus P is more than 10 to be able to use our normal distribution there. If we see our keyword mean, and usually that is just right in the problem, you can look for that keyword mean, then we're going to be doing the T statistics. That's what we're going to use to measure a mean. We should have a sample size of bigger than 30. And if we don't, then we need to know that the population should be normally distributed. And we were looking at a T statistic on those. And then it says, or are we measuring sigma or sigma squared, the variance? Well, we didn't really do that in this chapter, so we're probably not going to do that here either. So what I have now for us is just a set of example problems where you're going to need to choose what one would we do. So, all right, so proportion or mean. There we go. Okay, so Smarter Kids. A psychologist obtains a random sample of 20 mothers, so kind of small sample, in their first trimester. The mothers are asked to play Mozart at their house for at least 30 minutes. After 5 years, the child's given an IQ test. We know IQs are normally distributed, so it's okay that we have a small sample. And the mean is 100. If the IQs of the 20 children in this study have a mean of 104.2 and a standard deviation of 14.7, is there evidence that these children have higher IQs? Okay, so what are we going to do? Look for our keyword. So what keyword do you see in there that's going to help us make our choice? Mean. We know IQs are normally distributed with a mean of 100, and we are testing the mean of this sample. So in our hypotheses, as we set those up, in this problem, the null hypothesis would be 100 because we know that IQs are normally distributed with a mean of 100. That would be our null hypothesis. Is there evidence to suggest that these children have a higher IQ? So we're checking to see if the mean is greater than 100. Now the mean was 104.2, so seems bigger. Is it statistically significant? I don't know. We would have to actually plug it into StatCrunch and check, and we're not going to do that. Is it practically significant? I don't know. Is 4 IQ points really that important? Maybe, maybe not. I'm kind of feeling like probably 4 IQ points is not super significant. In October 1945, the Gallup organization asked 1,487 randomly sampled Americans, so nice big sample, do you think we can develop a way to protect ourselves from atomic bombs in case other countries tried to use them against us? 788 responded yes. Did a majority of Americans feel this? And then it gives us our level of significance. So, keyword. Well, in this one, it's almost the lack of a keyword. That's our hint. It doesn't say mean anywhere in here. Instead, our keyword, I would say, is majority. So then we're thinking about a proportion of the population. So our null hypothesis would be that that proportion is 50 because the question is, did a majority? So majority we think of as being more than half. So our null is 50. Does this study show that more than 50? So did a majority? So our null hypothesis would be greater than 0.5. According to the National Sleep Foundation, children between the ages of 6 and 11 should get 10 hours of sleep each night. In a survey of 56 parents, so good size sample, it was found that the mean number of hours the children slept was 8.9 with standard deviation of 3.2. Does this sample suggest that children are sleeping less than the required amount? Okay, so what kind of test are we going to do here? Looking for our keyword. Keyword, do you see our keyword? Our keyword is mean. Okay. It was found that the mean number of hours. So we're going to do a mean, which is our t-test. When we do means, we do our t-statistic. And we're going to be testing that the mu is 10 because that's the recommendation. They should be getting 10 hours. Our alternative, does this suggest that they are sleeping less than the required amount? Less than 10 is going to be our alternative hypothesis. And this is 8.9. That does actually seem like quite a bit less than the required amount. So this one might actually even be practically significant. If they're sleeping more than an hour less than they're supposed to, it does seem like they might be sleepy kids then. Oh, this is wordy. Okay, politicians form their positions on various policies through polling. Suppose the U.S. Congress is considering a passage of a tax increase to pay down the national debt. National polls suggest the general population is equally split on the matter. A congresswoman wants to poll her constituency to get a good sense as to how the citizens of her very populous district feel. Well over 1 million registered voters. She decides to poll 8,250, so she polled tons, but it's a really big district, so that's okay, still not too many. Of those surveyed, 4,205 indicated they are in favor, given blah, blah, blah. Okay, keep going. So, keywords. Again, in this one, it's almost the lack of a keyword. It does not say mean, and we are talking about how many are in favor of something. This is a proportion. So we would be doing a proportion test here. All right, I think this might be our last one. Quality control. Suppose the mean wait time for a telephone reservation at a large airline is 43 seconds. A manager with the airline is concerned that business may be lost due to customers having to wait too long for an agent. To address this concern, he develops a new airline reservation policies that are intended to reduce the amount of time that an agent needs to spend with each customer. A random sample of 250 customers, so good size sample, results in a sample mean wait time of 42.3 seconds, standard deviation 4.2. So did it work? Did this reduce the amount of wait time? What kind of test are we going to do? Looking for the keyword. Do you see the keyword? Mean. The keyword is mean. So we're going to do a t-test. The null hypothesis would be 43 seconds because that's how long it was. The manager wanted to reduce that, so the alternative is going to be less than. We're doing a less than test here to see if that mean wait time was reduced. Now, the average in the sample was 42.3 seconds. So even if this is statistically significant, and I don't know if it is, we would have to actually plug it in and check it. Even if it is statistically significant and we can say, yes, the mean wait time has been reduced, by how much? It's reduced 0.7 seconds. Is that going to make a difference in them keeping business? I'm going to go ahead and say no, that the customers probably aren't going to be like, oh, whew, I hardly had to wait at all that time. 0.7 seconds less. Awesome. I have all this extra time in my day, right? It's really not practically significant, even if it is statistically significant here. And that's the end. So in this section in your assignment, you're going to have mixed problems, you're going to have proportions, and you're going to have means. So look for those keywords. Ask me whatever questions you have. I'm happy to help, and I hope you have a great day.